Hi everyone, welcome back to this channel. So this is the third part of the ENA-X walkthrough setup, and in this video I'm going to focus on the spectrum analysis mode that's available in this ENA-X. So there's options to turn on in the network analyzer to convert it to be a multi-part spectrum analyzer, if you want to call it that. So this is a preset view. This is a default S11 general S parameter measurements. So let's go to setup for different class. And before we go there, unfortunately I don't have any signal generator that is able to help me with the modulation distortions, but I believe I have a video using the PNA instead. Same concept, almost the same setup. And we are not able to do it also because this ENA-X that I have is a two-part versions with single source, and as you might know, the intermodulation distortion measurements need two sources. So unfortunately these are the two things that we can't do in this series of video. Let's focus on spectrum analyzer today. So once you click that, it will go to the setup. I'm not showing the camera because it's the same setup using the same pre-amplifier for E5081A So let's set that to 1 gig and 4 gig. And then we have this advanced, so this is where you set RBW and BBW and whatnot in the spectrum analyzer. I haven't retried this converter. Again, I don't have a mixer to try out. If you bought a pulse options for this ENA, you're able to change that here, and it's able to generate out the pulse type signal for your device under test, especially when you have a very high power amplifier, high gain type, and you do not want to overheat that amplifier. Pulse is the way to do. So coherent, this is the one that's confusing. If you enable multi-tone here, it doesn't mean that it's going to generate multi-tone in the ENA. So what it does is it prepares ENA to be able to analyze multiple tones of signal that's going into the spectrum analyzer. So in detail, read through the help file. Just go to here, click help, and it will link to the right topic. So for example, this is a coherent area, so it will just explain a bit on that part. Let's go to source. So source, we have a couple of setups. So CW is just one single frequency signal. Let's turn that on. Let's change the power to -15 because that's what my amplifier can take in for now. And then once you're happy with that, click apply, and here's how it looks like. So we start from 1 gig to 4 gig, and our signal is at 1 gig. Let's change that. Click that, and then apply. So you can actually change the opacity of the setup so that you can see what's going on. So I'll change back so that it's easier to see. The other one that you can do is linear frequency. So linear frequency is sweep from start-stop frequency. So for example, I want to sweep from 1.1 gig to 1.6 gig. So number of points I want to, let's say we do it for 51 points. Just click OK, apply, and we start seeing that the signal is actually sweeping. So when do you need this? I have no idea. So you might need this sweeping frequency options for some tests that you want to run, because essentially ENA on the S parameter is also sweeping frequency. And the other one that I want to show you is also the power. If you want to do power, you can do this, and this is where you change the power range. And the last one will be linear frequency and power. So I think this is useful when you want to map out at different frequency, at different power level. It's similar to GCA, gain compression test, but it's not as easy as that. So we have a flexibility there. The point I want to bring out is that we have a flexibility to change whatever sweep that you want. So it's up to you. So it's actually as simple as that. So calibrations is really just to make sure that the power from port 1 and port 2 are calibrated correctly, and your jumper cable is taken care of, still using the e-cal or mechanical cal. So that's it. I hope this helped. It's just a quick video. Thanks for watching.